Okay, close your eyes for just a second and imagine the universe. If you're like most of us, you probably picture a silent, peaceful vacuum, right? Just this endless void of absolute quiet. But what if I told you that our universe is actually a roaring, violent symphony? Today, we are embarking on a cosmic detective story. We're diving into an explainer that uncovers one of the most baffling cold cases in modern astrophysics. It's a mystery that has stumped brilliant minds, sparked wild theories about alien civilizations, and ultimately forced us to rethink exactly what is happening in those dark spaces between the stars. To really grasp this mystery, we first have to understand the environment of the crime scene itself. Now, you might be wondering, if space is a true vacuum, why on Earth is it so loud? Well, researchers with the North American Nanohertz Observatory for Gravitational Waves, usually just called NanoGraph, have actually spent the last 15 years proving that the universe is humming, literally humming. By tracking the exact arrival times of radio pulses from rapidly spinning dead stars across the Milky Way, they found some incredibly compelling evidence that space-time itself is rhythmically stretching and compressing. It's this very low-frequency rumble constantly rippling through the fabric of the cosmos. Okay, let's dive right into this. This cosmic symphony, it is completely chaotic. I mean, it's made up of the gravitational waves from hundreds of thousands of pairs of supermassive black holes. We're talking monsters weighing billions of times the mass of our sun, slowly spiraling toward each other over millions of years. Throw in the catastrophic explosions of dying stars, plus the high-speed ticking of millisecond pulsars, and you have a universe that is just incredibly noisy with electromagnetic and gravitational radiation. Finding a single isolated anomaly in this kind of environment is literally like trying to find a needle in a cosmic haystack.
Section 1. The Millisecond Mystery.
So, our inciting incident was a signal that cut right through all of that chaotic background noise of the universe. It was loud, it was sudden, and it completely defied explanation. It was a fast radio burst, or FRB. Simply put, it's a mysterious transient radio pulse. And when we say transient, we mean blindingly fast. We are talking lasting only a few milliseconds. Yet these signals were originating from unimaginably distant sources, literally billions of light years away from our own galaxy. Figuring out what could possibly generate a flash of radio energy that bright and that fast from that far away, well, that became the ultimate cold case for modern astrophysicists. Our timeline here actually begins with a total accident. The very first fast radio burst hit the Parkes Observatory in Australia back in 2001, but nobody noticed. It just sat there, hiding in archives of old pulsar data for 6 years. It wasn't until 2007 that astronomer Duncan Lorimer and his student David Narkevic were combing through that archival data and spotted this sudden, massive spike. They caught it purely by accident. Imagine this for a second. That first detected signal, which we now call the Lorimer burst, lasted just 3 milliseconds. That is 3/1000ths of a second. Yet, in that microscopic sliver of time, the source of that burst output several days' worth of our sun's total energy. Just let the sheer scale of that power sink in. It's almost unbelievable.
Section 2. Aliens or appliances? Searching for the source.
This staggering realization launched a massive, high-stakes investigation. Astronomers all around the globe scrambled to figure out what could possibly cause such an incredibly energetic flash out in the distant universe. Naturally, when scientists encounter a highly energetic, patterned signal from deep space that they can't immediately explain, well, some pretty wild theories start flying around. One of the most thrilling hypotheses proposed by some researchers was that these FRBs were actually powerful, misaimed alien radio signals. The idea was that advanced extraterrestrial civilizations might be using massive energy beams to charge light-driven cosmic ships across interstellar distances, and our telescopes were just sort of catching the stray flashes. But the alien theory quickly met a hilarious reality check. A researcher named Sarah Burke-Spolaire was digging through more archival data from the Parkes Observatory and actually found similar fast bursts. But there was a catch. These signals seemed to come from all over the sky, they only happened in the middle of the day, and specifically only when the observatory's visitor center was open. After an exhaustive detective search, they found the culprit. It wasn't hyper-advanced aliens. It was a malfunctioning microwave in the observatory's cafeteria. When someone pulled the microwave door open before it was finished cooking, it emitted this tiny radio sweep that the highly sensitive telescopes picked up. They ended up calling these localized fake signals peritons. But here's the crucial thing. While the microwave mix-up is a brilliantly funny red herring in the history of astronomy, the actual fast radio bursts, like the Lorimer bursts, are undeniably real. The data clearly showed that true FRBs exhibited a specific frequency sweep caused by traveling through the vast, dispersed plasma of intergalactic space. They were definitely coming from billions of light years away, far beyond the reach of any earthly cafeteria appliance. So the true cosmic culprit was still at large. Section 3. The Magnetar Breakthrough. Solving the mystery. So for over a decade, astronomers managed to catch a few dozen more of these elusive bursts, but their origins remained a total mystery. That is, until the cosmic stakeout finally paid off in 2020 with a massive breakthrough right in our own galactic backyard. On April 27, 2020, the Neil Gehrels Swift Observatory detected a storm of X-rays coming from a known stellar remnant inside our very own Milky Way. The exact next day, the CHIME telescope in Canada detected two bright, fast radio bursts coming from that exact same location. Immediately, an automated alert went out, and a global fleet of radio and X-ray telescopes swiveled to monitor the source. We had finally caught the suspect red-handed. Now, what's really interesting about this is that our culprit was finally identified as a magnetar. If you aren't familiar, a magnetar is a special type of neutron star, basically the ultra-dense, collapsed core of a dead massive star. But what makes magnetars unique is their magnetic fields. We're talking fields that are trillions of times stronger than the magnetic field we experience here on Earth. They are literally the most magnetic objects in the known universe. Thanks to those incredible observations in 2020, we can finally piece together the anatomy of an FRB. Just like the Earth has earthquakes, these highly compressed dead stars experience violent starquakes. As the magnetar spins, its intensely complex magnetic fields can twist, tangle, and then abruptly snap. When this happens, it actually fractures the ultra-dense crust of the star. This violent shift triggers a massive, instantaneous cascade of electromagnetic energy. In the blink of an eye, a colossal burst of radio waves is dumped out into space. A millisecond flash, powered by a dying star's quake, visible all the way across the universe. Section 4. The New Era of Discovery. Multi-Messenger Astronomy. Solving the origin of FRBs did a whole lot more than just close a cold case. It actually proved that we are entering a brand new age of multi-messenger astronomy. We don't just look at the universe in one way anymore. We're combining incredible new tools to watch it unfold in real time. The future of this cosmic stakeout is just incredibly bright. We are no longer relying on single, lucky radio detections. We're actively combining gravitational wave data from massive black hole mergers, X-ray flashes, and radio pulses. We have the James Webb Space Telescope probing the earliest days of galaxy formation. And very soon, the Vera C. Rubin Observatory down in Chile is going to begin its survey. This massive digital camera will scan the entire visible southern sky every 3 to 4 days, looking for anything that changes. When a star explodes or a massive black hole tears a star apart, the Rubin Observatory will generate a worldwide scientific alert within 2 minutes of capturing the image. And this brilliantly illustrates our new understanding of the cosmos. As the team behind the Rubin Observatory perfectly puts it, while the night sky seems calm and unchanging to the casual viewer, it's actually alive with motion and transformation. We are watching a dynamic cosmic movie now, not just a static photograph. So we've figured out the humming of gravitational waves, and we've finally unmasked the magnetars behind fast radio bursts. But our universe is vast, it's ancient, and it's endlessly creative. As our instruments grow sharper, our software gets faster, and our cosmic ears become even more sensitive to the roaring symphony of space, what breathtaking anomaly are we going to hear next? I really hope this explainer has given you a whole new appreciation for the loud, violent, and deeply fascinating universe we live in. Keep looking up and keep questioning the quiet.